Hello, my name is Anna Wagner, and I am an undergrad research student in the Meat Science and Muscle Biology Lab in the Department of Animal Sciences. Pork is the most widely consumed protein in the world. Data from Pork Checkoff indicates that about 40% of the meat consumed in the world originated from pork. Among all of their pork cuts, pork loin is the most commonly purchased fresh pork product. This indicates its popularity among the consumers. While pork is widely consumed, increasing issues with pork loin palatability have been observed. Recently, pork loin product was shown to be tougher and drier. Additionally, it was also suggested that lower flavor was perceived from pork loin product. This increasing problem is potentially due to the low marbling and high lean content in pork. While there are techniques to improve pork palatability, most of these techniques use injection enhancement using non-meat ingredients that involve further processing. This is not an ideal method for consumers. As consumers are now demanding a more natural product, there is still a need to develop a natural post-harvest process to improve quality and value of pork loins. Postmortem aging is a natural value-adding process. Endogenous enzymes work to break down the meat. Calpain is one of the most important enzymes that work to degrade myofibrillar proteins postmortemly to cause tenderization. Aging is also a common way to improve the palatability of meat. There are several types of aging practices. Wet aging is the one commonly used today that encloses meat in vacuum-packed bags. Dry aging is another aging method known as a natural method to enhance the palatability of meat, to increase flavors such as umami, sweet, and nutty, and to increase juiciness. The practice of dry aging has been practiced for a long time. Meat is stored in controlled environmental conditions without any protective packaging. Dry aging has also been shown to improve meat palatability of low-marbled grass-fed beef. This is significant as grass-fed beef is known to be tougher due to less marbling. This poses the research question, could dry aging be used as a natural value-adding process to improve the palatability and quality of pork loins? In this study, we evaluated the effects of different aging treatments on pork loin quality attributes. To prepare our samples, bone-in pork loin from one side of 10 carcasses were collected at 2 days post-mortem, split into 3 sections and randomly assigned into 3 aging methods: wet aging, dry aging, and UV dry aging, which is dry aging with UV light treatment for microbial growth. All loin sections were aged under the same controlled conditions for 21 days at 2 degrees Celsius, 65% relative humidity, and 0.8 meters per second airflow, rotated weekly. For UV dry aging, UV light treatments were given 2 times per day with a dose of 5 joules per centimeter squared for each treatment. At the end of aging, samples were trimmed by removing the layer of crust around the meat, obtaining steaks for further analysis. Several analyses were performed after the completion of aging. Total salable yields was determined for each aging method. The extent of tenderization was assessed by using texture analyzer set for Werner-Prosser shear force measurement. Water holding capacity of the samples was determined through multiple assay observing its freezing thawing loss, drip loss, and cooking loss. Microbial analysis was performed for aerobic bacteria, lactic acid bacteria, yeast, and mold. Color stability of the chops were then determined through simulated color display over 7 days and objectively measured using Hunter calorimeter. Oxidative stability of the samples was measured by looking at the extent of lipid oxidation through T-bars assay. And lastly, a consumer sensory panel of 120 panelists was used. Statistical analyses used balanced complete block design with the PROC mixed and PROC Glimex procedure. Now we get to move into the results. If you're not familiar with dry aging, this is how it looks. Here you can see the progression of dry aging as the sample's crust becomes darker with time from left to right. From left to right, UV dry aging, and wet aging loins are shown. UDA and DA are both darker on completion of aging. And once the crust was trimmed, the samples appear similar. In this table, least square means of loss during dry aging of pork loins are shown. A and B, different superscript letters, indicated a significant difference between the different aging methods. Dry aging and UV dry aging resulted in greater shrink and trim loss as compared to wet aging. The lower yield of dry aging and UV dry aging pork were observed mostly due to trimming, which was expected due to dehydration during the aging process. It was observed that UV dry aging attained a greater pH value compared to that of wet aging and dry aging. Drip loss as well as freeze-thaw loss obtained a significant difference between wet aging from dry aging and UV dry aging. In each test, wet aging displayed the highest loss, followed by dry aging, then UV dry aging. Cook loss display indicated that there is no significant difference among treatments. There was also no significant treatment effect observed for shear force. All treatments have a Warner-Brotzer shear force value in the range of 25 to 27. The use of dry aging process increases water holding capacity of pork loins compared to that of wet aging. By analyzing the concentration of microbes on the UV dry aging crust, showed that UV light significantly decreased microbial contamination on the surface of the meat. Of all microbials, LAB was found significant in the lean portion, showing greater concentration compared to all other treatment, but all microbial concentrations are still below spoilage limit. Color display is shown, wet aging, dry aging, then UV dry aging from left to right. Dry aging was significantly darker due to lower moisture content. An overall decreased trend was observed during the color display. However, B-star and chroma were not significantly affected. Starting from the left, lightness, or L-star, showed lack of significant difference among dry aging and UV dry aging. Wet aging, conversely, had a p-value of significance. The color trait for redness, A-star, showed a decline over time. This could potentially have a negative effect on consumer preference, as a darker color meat may be unappealing. Yellowness, or B-star, results proved not to have significant difference, but a sharp decline among treatments after day 3 of display. Hue angled was measured for discoloration and depicted with an upward slope indicating an increase in discoloration over time. Significant interaction effect was observed, beginning in day 5 of display, showing greater discoloration in both dry aging and UV dry aging when compared to wet aging. The chroma values for pork color intensities were not significantly different. Lipid oxidation showed insignificance among sample means. No significant difference was observed on day 1 of display for all treatment. The T-bar's value significantly increased after the 7th day of display. However, wet aging had a lower lipid oxidation increase. Since dry aging is exposed to an external environment as opposed to wet aging, dry aging would have higher levels of lipid oxidation. The increase of oxidation in dry aging treatment might affect palatability development. The consumer pre-survey showed that panelists from a variety of demographics value flavor as the most important palatability trait to them. The majority of these panelists also preferred medium doneness. The consumer post-survey showed the panel had a previous experience eating dry-aged meat, mainly from a restaurant, and some have even tried making a homemade dry aging themselves. The 120 panelist consumer sensory indicated there is no significant difference among the treatments. This could be due to the consumers not being familiar with fresh, dry-aged pork product and not yet accustomed to its palatability attributes. In summary, the duration of aging has more impact on meat palatability attributes than different aging methods. The dry aging process increases water holding capacity of pork loins compared to wet aging. Consumer analysis found all pork chops from different aging methods are acceptable, and microbial shelf life was found acceptable. We can conclude that dry aging could potentially be utilized as a natural value-adding process to improve pork loin quality. Being aware of the effect of dry aging meat can give knowledge to many meat producers on how to prepare their meat to obtain the best effect for their consumers. For future studies, we can use trained panelists to better quantify results, as these panelists are better accustomed to dry aging and its palatability attributes. We can also study the components liberated through the dry aging process through volatile chemical analysis. Thank you!